Welcome to aminacademy.com. In fluid mechanics, let us discuss about hydrodynamically smooth and rough boundaries of the pipe. For turbulent flow analysis along a boundary, the flow is divided into two portions. The first portion consists of a thin layer of fluid in the immediate neighborhood of the boundary, where viscous shear stress predominates while the shear stress due to turbulence is negligible. This portion is known as laminar sublayer. The height of the height up to the effect of viscosity predominates in this zone is denoted by delta days. This height. The second portion of flow where the shear stress due to turbulence are large as compared to viscous stress is known as turbulent zone. Now, if the average height K of the irregularities projecting from the surface of boundary is smooth less than delta days, the thickness of laminar sublayer is shown in the figure. The boundary is called smooth boundary. This is smooth boundary. This is because outside the laminar sublayer, the flow is turbulent and eddies of various size present in turbulent flow try to penetrate the laminar sublayer and reach the surface of the boundary. But due to great thickness of the laminar sublayer, the eddies are unable to reach the surface of irregularities and hence the boundary behaves a smooth boundary. This type of boundary is called hydrodynamically smooth boundaries. Now, if the Reynolds number of the flow is increased, that means due to speed of the liquid flow, the turbulent flow happens. That means thickness of the sublayer will decrease. The thickness of the sublayer become decreasing. If the thickness of the sublayer becomes much smaller than the average height of K of the irregularities of the surface as shown in the figure here, the boundary will act as rough boundary. This is because the irregularities of the surface are above the laminar sublayer and the eddies present in turbulent zone will come in contact with the irregularities of the surface and lot of energy will be lost. Such a boundary is called hydrodynamically rough boundary. In rough boundaries, energy lost is more than smooth boundaries. Now consider this concept now. First one, if K by delta days is less than 0.25 or K by delta days is less than 0.25, boundary is called smooth. It's called a smooth boundary. The second, if K by delta days is greater than 6.0, the boundary is rough. If 0.25 is lesser K by delta days and lesser than 6.0, boundary is transition. Now, in case of roughness, In case of roughness, Reynolds number, that is U star K over kinematic viscosity. Now we'll discuss this one. Due to, in case of roughness Reynolds number, we'll use if U star K over V, that is kinematic viscosity, is less than 4, boundary is considered smooth. And if U star K over kinematic viscosity lies between 4 to 100, that boundary is transition. It is in transition. Now, third, if U star K over V is greater than 100, boundary is rough. Now, we'll talk about velocity distribution. Distribution of turbulent flow in smooth pipe. Flow in smooth pipe is given by formula equal, that is U over U star equal 5.75 log of base 10 U star Y over kinematic viscosity plus 5.55. Next, same for velocity distribution for rough pipe. For rough pipe, velocity distribution of turbulent flow in rough pipe, we can write the velocity distribution formula is that is U over U star equal 5.75 log 10 Y over K Y over K plus 8.5. This is the two formulas you have to remember. We have done. Please subscribe our YouTube channel.